Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so this question here on looking at histograms and looking at their shape is from 2012. It was a sample paper and it was question 2. So the shapes of the histograms of 4 different sets of data are shown below, A, B, C, D. Part A, complete the table below indicating whether the statement is correct or incorrect with respect to each data set. Okay, and you know what, when I read that, I wonder, do you lose marks if you don't put the X's in? Just wondering when they said it like that. Okay, so the data is skewed to the left is the first one here. Okay, so skewed to the left. Okay, so for skew, I suppose the trick of the trade is to follow the tail. Okay, so that means I'm going to show you that it's actually C. This is the tail of the data. So you can see it has tailed all the way down here, whereas this one is a positive tail or skewed to the right. Okay, and this is what we call a negative tail or skewed to the left. Okay, so follow the tail for the skew. So C is the only one that is skewed to the left. Okay, skewed to the right then is A, like we just said. The mean is equal to the median. Okay, let me clean up the charts. The mean is equal to the median. Okay, well, one of the important things about a normal distribution, which is B, well, there's a couple of things. It's symmetrical, really important. And by nature then of it being symmetrical, it means the mean is bang on in the middle. It also means the median, which is the middle value, occurs in the middle. And it also means the mode, the value that occurs most often, is there in the middle. Okay, so that's the normal distribution. That's the properties of it. So for sure, the mean is equal to the median for B. Now, this is the one to watch, which is D, okay? Because this one also has the mean in the middle. If I could draw, okay, the mean in the middle. So that's the value, that's the average, okay? Yes, it has low values, yes, it has high values, but if you think about them, they'll cancel each other out, okay? So the average, which is the mean, is still going to occur in the middle, okay? The middle value is also going to occur in the middle, so that's the median, okay? Now with D though, the mode doesn't occur in the middle. Mode is the value that occurs most often, so it's the highest peaks. So this is what we call bimodal data, so it's got 2 modes, the 2 extremes, okay? But for the purposes of this question, the mean is equal to the median. Now the mean is greater than the median, so in which ones is the mean greater than the median? Okay, well, the mean was equal to the median for B and D, so it's either going to be A or C, okay? And this is where you have to understand skew and what it does to the mean, okay? So if we have a look at A, and you think about calculating averages. So in averages, you add up all the numbers and then you divide by the number of numbers, okay? So if you have more big numbers, like we have here, than you do little numbers, or skew like we have here, then it's going to pull up your average, okay? If you have a load of little numbers with skew, it's going to pull down your mean, okay? Then where does your median lie? Well, you've got to think about median being the value in the middle, okay? So you have to roughly try and eyeball them and see, well, where is the value in the middle? Now, it's kind of hard to do, but I'm going to guess it's somewhere here. And then maybe somewhere here. Okay, whereas your mean is going to be up higher than that because that tail is going to pull up your mean and this tail is going to pull down the mean. Okay, so the mean is greater than the median when you've got a positive tail. There's a single mode. Let's clean up our charts. Well, there's definitely not a single mode in D. There's two of them. There is a single mode in C. There is in B. There is in A. So I'm just seeing, is one of the bars of the chart higher than all the rest? Yes, they are. So that's how I can say there's a single mode. Remember, on a histogram, this y-axis is frequency, or how often it occurs. So there is a value that occurs most often. So that was part A. Part B then, assume that the 4 histograms are drawn on the same scale. State which of them has the largest standard deviation and justify your answer. Okay, if we go back to the last recording that we had, we looked at standard deviation and the formula for it. And it was, I'm going to try and remember it off the top of my head, each of the values minus mu squared over the standard, over the number of numbers or something like that, over n, yeah, the number of numbers. So something like that. I may not have it perfect, but that is standard deviation. But it's the bit in the bracket that I'm interested in, okay? So you take each of the values and you compare it to the mean, okay? So what does that mean for standard deviation? Okay, well, the smallest value of standard deviations is when this distance is the smallest. Okay, so which means that if you have values very close to the mean, then you're going to have a very small standard deviation. Okay, so the normal distribution, for example, has a small standard deviation. Okay, because the bulk of the values center around that mean. This one would have the largest standard deviation because there's your mean, but the problem is the bulk of the values here and here are the furthest distance away from that mean. So when you do this subtraction and you square it so that you don't cancel them out, so that the negative ones get squared to be positive, you're going to have the biggest differences here. So therefore, you're going to have the biggest standard deviations. And they will be bigger than these two. So A and C are bigger than B. However, D is the biggest one out of all. So D, and how would I describe it? Standard deviation measures the distance from each point to the mean and gets the average of that. The majority of the points in D are furthest from the mean. Or something to that effect. Okay, so therefore D will have the highest standard deviation. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.